Hello everyone, welcome to the SoLeadSaturday episode 7. The guest we have today is one of the leaders in the data science areas. We already learned a couple of things about him, and today we will explore much more about him as well as his passion and how did he manage to be one of the leaders in the areas he was passionate about. So let's just welcome him. So thank you, Beau, for being on the
Thank
SoLeadSaturday podcast. I really appreciate your time. I can imagine that it's very early morning for you.
you.
So
Yeah,
thank
very happy to be here. Thank you
yeah,
so much.
yeah. Thank you so much for your consideration. So to begin with, actually, I'll start with your I looked into your profile. So when I see it, it is like, you tried your hands in multiple things. Like you worked in a data science, you tried your hands in the entrepreneurship, you did the instructor, like you worked as an instructor at the boot camp and you worked as a chief data scientist. You right now do as well. So, what did you enjoy the most and why?
Yeah, that's a good question. So you left out that I had a couple of years where I worked as I worked in intellectual property law. So so that's even more different from data science than those
Mhm,
other things on the list. So the way my career has been an evolution to finding out more and more of where my real skill set is and what
mhm,
I enjoy doing. And so what I'm doing now
mhm,
is what I enjoy the very most. I'm working with multiple companies.
mhm,
Um, so my own consulting company, Method Data Science, but I'm working with a lot of different clients and a lot of different industries and helping them solve data science problems,
mhm,
helping them their own solution, data science solutions,
mhm.
and that what I'm doing now is my most favorite and what I enjoy the most, and that's by design. That's very intentional.
Yeah, so that is the more important, I guess. What you do, you should enjoy that. Uh, so,
Absolutely, passion makes a huge difference,
yeah.
and not only your own mental health and enjoyment, but it follows through in the quality of your work. So,
Yeah, so it moreover like I feel you then never get stressed out if you are working in the area you are
mhm,
passionate about.
Yep.
Otherwise, it is more or like you are stretching your hours and you are not enjoying more.
Yeah, so I mean, stress always happens, but the stress of something that you enjoy and that you chose to do is a lot different than
Mhm.
something you're being forced to do or that you don't like doing. So
Yeah, true, true. So moving to the next question, what is the chief data scientist role in any organization and how does it bring value to the business?
yeah, so this is a good question,
Mhm,
and it varies on the organization and on the organization size. So my experience is mostly with small and mid-sized companies.
mhm,
I have not worked for any very large organization as part of my data science career. So the role in that I've experienced of chief data scientist is very much helping a company define a data science strategy,
mhm,
help them setting up the team and the data science initiatives at the very beginning of the company, so that 5 years later,
mhm.
um, you know they don't look back and say, oh, I wish we would have done this differently. um,
Yeah.
so er, early to a company, it can start very basic of like, what data do you have? What data should you be collecting? How is that data stored? What needs to happen to that data before we can do anything with it? Those are all kind of typical data engineering things, but when you're coming into a small and mid-sized company, they often have none of that infrastructure in place at all.
Mhm,
Um, and so I think that the role of a chief data scientist is to um, help bridge the gap between the very technical uh, side of the business of the
mhm,
data scientists, and help translate what they need to do uh, into something the executives understand, and so that
mhm,
the executives have the right expectations of how long things take, and how to interpret and use data science, but then translate back so that the data scientists aren't working on things and spending time on things that aren't going to have a value to the business.
Mm-hmm.
And so it's very, I mean, the person that you have in between the executives and the data scientists doing the work, it's incredibly important. That can make or break the success of data science in any organization. It is a translation. Executives speak a drastically different language than data scientists. Data scientists talk about RMSE and AUC and all these other things, and that means nothing to most CEOs.
Yeah,
And like
it's just the academic.
so.
When it comes to real situations, I also feel like that way, because when I deal with any use case in the bank, it is like bank's
Mhm,
data is like, I feel very dirty.
mhm,
And
mhm,
then it's like, yeah, that doesn't, those values doesn't make sense if you don't have the proper data.
yep.
So yeah, yeah. Uh,
Yeah. So I think the chief data scientist role is very important. You need someone that understands the business, but also intimately understands the technical side
mhm,
of what needs to happen. I've been a part of teams where the VP of data science or the data science manager is not a data scientist, does not code, does not program, has never done that, and
mhm,
um, that can be a huge problem too, because they'll say things like, you'll explain, this is going to take this amount of time to build this out, and then they'll say things like, well, isn't it just doing this, and they'll really oversimplify what needs to happen, and um, a lot of times, the steps that you need to take in code to make something happen are a little more complex than just saying, you know, isn't isn't this all that, isn't it just this? So
yeah,
anyway.
I got it actually. So it's quite complicated when it comes to the business. But when we say that, chief data scientist, like, um, is it like you are the person who is going to decide on the when the solution needs to be get to the organization level or not, like when you find any benefit in any particular use case? Once the benefit analysis is done and the feasibility testing is done, are you the person responsible to advise on whether that goes on the larger scale, or how is it like?
Yeah, and this depends on the size of the organization, absolutely. Um, but typically in the work that I do, yes, I'm the gatekeeper that can say, okay, we have we have all of our bugs ironed out. We have very good performance out of sample performance. And then we've done our QA and our testing,
Mm-hmm,
and now it's ready for the business users to actually
mm-hmm,
consume and use whatever we've built, or use whatever model we've trained. Um, and in a lot of organizations, it's either the chief data scientist that
mm-hmm,
decides that, or he has people that has in place of, he or she have people that they have in place that do that QA process,
mm-hmm.
that, that it's
Yeah,
ready. So
yeah, okay.
it really depends. So.
Yeah, that's true. It depends upon the organization a lot as well.
mm.
So moving to the next question, how do you define all the phases of data modeling, and what is the best strategy to get more accurate model and results? Any favorite tools to show the results or something like that?
Okay, so
There are like a three
this
actually bunched together.
yeah, so this is another one of those questions that depends on the problem
Mhm,
that you're answering. And I think the very most important step that is often jumped over in organizations is clearly defining, what is it that the business needs,
mhm,
before you start data modeling. What is it that they're trying to accomplish,
mhm,
and that's very important for determining your next steps. So you have, so that I think is the most important. Do they need, um, that'll tell you if they, the algorithm that you need to use is a continuous predictor, or the categorical analysis, or something else like that.
Mhm.
that'll tell you of what level of accuracy do they need. Do they need,
Mhm.
um, are they okay with 80%
Mhm.
accuracy, or do they need 99.9%? And what caveats with the data do you need before you go into data prep and figuring out what they need. So that's the first stage.
Mhm.
Second stage, it is your data prep of actually getting your data in a format that you can actually run a model or analysis. It may be bringing in uh, multiple different data sets together. Maybe um, and I like to know what the end result is going to be. Is this kind of a one-off project where the executives are interested in kind of a one-time answer, or is this something that we're going to want to put into production? And as I'm doing the data cleaning and that step, I have that in mind.
Mhm.
Um, because is this a process that I'm going to need to scale and build in to something that is going to be used over and over? And sometimes you architect that differently.
Yeah.
Um, and then typically you might have a feature engineering, feature selection kind of phase where you're really in the data trying to understand how to get the most uh, the most signal or the most predictive power out of your data set. And that's often a very iterative process. You go from data cleaning, data engineering, feature selection, and modeling, and you may circle back in that loop multiple times. You may have results of modeling and say, okay, I'm going to try adding these features, or given what I know about the domain, if I transform this one variable and times it by this other variable, or if I engineer this particular variable, that may have a huge impact. And
Mhm.
for me, this is the part of modeling that actually is science.
Mhm.
Where you're uncovering truth about your data set, and typically, um, you know the best models in my experience aren't kind of the auto ML,
Mhm.
throw everything in, um, just see what comes out, kind of what everyone talks about is black box. It's ones where a lot of times the most value to the business is where you've spent time in the data,
Mhm.
and you understand intimately what types of variables are predictive,
Mhm.
and what is the mechanism behind of you explain why, and you don't, um, and that doesn't mean that you
Mhm.
have an explainable model, like XGBoost or neural net. um, those you know those aren't as explainable as like a linear regression, but you can still understand intimately all the inputs that go into your model, whatever the end result is, and understand why, if you're predicting disease, why these types of proteins are particularly important in your model, and I think that's an important.
Mhm.
um, and how we show the results really depends on the business. I it's very important, that there's ways that data scientists look at results,
Mhm.
and then there's ways that the business look at the results, and often the metrics that we use as data scientists
Mhm.
don't mean anything to a business. You'll
Yes.
show them and say, look at how good this RMSE is, and they're like, I don't know what that means, I don't know how to interpret that,
Yeah.
I don't care about that. And so you have to find a way, one, to either educate them about why, what is a good model,
Mhm.
and how do you know that it's good, but what does that mean for the business?
Mm.
um, so um,
So I feel it is, to conclude, it is more over like when it comes to the data modeling, it is more over like iterative method. Like you build one model and then you fine tune it as per like, you start understanding
yep,
more
yep,
about data. And then,
yep, and
yeah, and it is always a
it's
collaboration, taking the inputs from the business and then try to get as much as inputs you get, actually, it would be better to uh, build the better model, I guess.
Yep. I I've had um in my career where I've built something very cool, very accurate, or a new innovative approach, and simply because the business didn't understand it,
Mm-hmm.
that even though it worked and it did exactly what they needed, because they didn't understand it, it was too
Yes,
complex for them. It didn't get implemented.
that's
You
true.
know,
That
and,
happened actually in my prior employer, that I did one matrix, like after building like doing the data modeling, I did come up with some metrics actually, and then I went to the billing director to show about the health insurance data, and he was like not at all interested in how fancy those values are, how accurate those values are. It was like he was very easily able to understand the data. So data understanding is more or like a base,
yep,
um, and then after data cleaning actually after that.
yep, yep,
Yeah.
yep. Yeah, no, that can be very frustrating if you go through the end of the process of spending all this time on a model and to have it not get implemented, even though it's a great model.
Mm,
And so that's why the very first step that I mentioned is so important, and I would really press the business of how you know that this is a good model.
mm,
Not how a data scientist will know it's a good model, but how will the business know it's a good model, and what will it take for them to trust it and use it, and make sure that that. Some businesses this won't be a problem, but others,
mm,
I've worked with companies where they just said, some people in the organization have the attitude that science produces is a black box, and we don't trust black boxes.
mm,
And so that's a really hard thing to go to face as a data scientist. So
yeah, that's true.
um,
Yeah, yeah, yeah. That's useful actually, useful insights to anybody to know that how it is like, when you learn in the academics, it is a different approach. But when you actually try to implement the real projects, it is more or like a learning again,
mhm.
because you have to
Yep.
understand a lot more dimensions in the business, and then you have to go for it. So that's very useful. Thank you for that. The next question is around the same thing actually. We talked, you deal with multiple domains. So how hard it
Mhm.
is when it comes to data to deal with different kinds of data to understand and build models on, and how one can achieve that if one has to deal with multiple domains like.
Yeah. So that's a good question.
Mhm,
And on one level, um, domain doesn't matter because the problems with data are the same in any industry. At a high level, you have issues with messy data. The
mhm,
types of models that you use can be
mhm,
the same in any industry to solve lots of different problems.
mhm,
But on the other hand, domain knowledge and domain understanding is very important because there's all kinds of caveats and exceptions and ways that you should interpret data, that in order for your model to be useful to the
mhm,
business, domain understanding is very important. And so this is one reason why I think data scientist needs to be a curious person and needs to like learning about things even outside of data science.
mm,
you
yeah,
know under and this comes back to, I think, what makes a good scientist. A good scientist is curious.
yeah,
And this is something that I had to do as an ecologist, and this is something that I ecology covers a lot of different domains. I had to go and
mm,
learn about geology, or I had to go and learn about soil chemistry, or go and learn about botany, just to solve the questions I was interested in. Also, when I worked in patent law, uh, draft patents in a bunch of different industries, and you have to go and learn about how oil rigs work in enough detail that you can draft a patent about it, or you have to go and learn about how gene therapy for treating cancer, how that works in enough detail that you can describe the protein interactions, and in a way, those that same type of skill has really served me well as a data scientist, because you're essentially studying the domain that
mm,
you're modeling. In order to model it accurately, you need to understand it. And Part of data science that's really exciting to me when I have the opportunity to learn about a new domain. The tools that I use, data science tools, can be applied in any domain. Those are standard. The statistics, machine learning, programming skills, those can be applied in any domain. But how you apply them is very, it can be very dependent on the requirements of the business, but also the specifics of the industry that they're in, and the type of data that they have. And so you have to be curious and wanting to learn about how
Yeah.
that works.
Like I have a question, like, when it comes to data, how to get like data definitions? Like if you don't get it through the business or something like that, how one can achieve that actually? That is kind of a real challenge I also see. Like sometimes you don't get the proper data definitions, or you don't know much, you don't understand much
So
of the features.
it is very it's very rare in my experience, especially working with smaller companies and mid-sized companies like I have, that their data is documented, if at all. And so I've almost never seen a good data dictionary. And I what it comes down to is data scientists need to ask questions. They need to figure out in their organization, who are the people that might know this information, who are other people. So if you have let's say you have a database that's storing information, and there's not good documentation of it, then you need to figure out who are the software developers that are maintaining it, and you'll need to ask them, okay, where's this data coming from? Why are you storing it this way? How do I best access it? You might need to talk to the business users who are using that data in another context to say, okay, why is this data important? Why do you use this over that? What do you look for that is most important? And you're doing science. You're figuring out how this system works so that you can appropriately model it, and have have the right kind of impact.
Yeah, that makes sense actually, and something that I can relate as well. So moving to the next question, again the same, actually it is along the same line, we covered it already, that how much domain knowledge is needed when while working. It is important actually, basically. So you need to understand little, at least basic understanding should be there.
Well, and I think that helps. But I think more important that is that you're willing to learn the domain knowledge, and you're able to do it quickly.
Yeah.
So I will take in a project in any domain and understand that there's a little bit of a learning curve, but that's because I enjoy learning new things. I enjoy learning about new domains, and in what I do, I find that I'm very much a generalist, and the more different types of projects that I'm involved in actually allows me to have more creative solutions, because I say, okay, in this completely unrelated domain, something this way, that actually can apply in this other domain, if we do it a little bit differently, and I'm able to draw connections and be creative and think kind of outside of how domain experts might think, and that's trade-off with domain understanding is it's important to understand the domain, but if you get too entrenched in it, you'll be stuck. You'll be stuck in the way that the domain has always done things, and being stuck and doing things the way they've always been done, that's the opposite of innovation. That's the opposite of progress, and change. So you need to understand what they're trying to accomplish and what's important, but also have the flexibility and freedom to realize that there may be a better way to accomplish what they need, than how they've done it before.
Yeah, that makes sense. Thank you for that. Moving on to the next question, it is about what would be the best approach to achieve the good data quality?
So, a lot of times scientists have no control over this, because we're not responsible for data collection. But when I come in a new company, a lot of times I can I can help influence this.
Mm-hmm.
And I think understanding what is collected, why it's collected, um, understanding the assumptions that go into it. So I just had a case where, um, you know, I improved the data quality that we were getting in because they were doing some conversions from data in one form to another.
Mm-hmm.
And the model that they were using to do that was not that accurate. And so by improving that model, that improved the data quality that we used for modeling the end problem. You know, so I understanding the assumptions that went into creating the data,
Mm-hmm.
you know, were very useful.
Mm-hmm.
So
Yeah,
yeah.
yeah, that makes sense. Just give me a minute, actually. My niece is laughing actually in between the
Okay.
video, so I'll just ask her
Okay.
to don't do. Okay, so resuming back, the next question is, any particular case study on stock market prediction or disease prediction you would like to share and provide your insights on, like any interesting use case that you worked?
Yeah. So trying to think of so trying to think. So sometimes it's hard. I should have thought about this before because you gave me the list. But some things that I can't share because I'm covered by NDA. So even though it's really interesting, I'm not allowed to share about it. Um, so
Maybe you can just discuss about the approach. Like if suppose you are going for the stock market prediction, there is a lot of use cases available online as well, right? So how much that would be useful when.
yeah, so I haven't done as much in stock market. So I
Mhm.
have worked in the financial markets of helping predict. So the last company that I worked at full time actually just stopped working there full time in January.
Mhm.
They, you know, they're a financial investment management company, but they are in the life settlement space. So they buy and sell life insurance policies
Mhm.
that people don't want to pay their premiums on anymore. So if you have a life insurance policy, you know, you have to pay premiums
Mhm.
every month or every year or whatever, in order to get that benefit for your family when you die. And be a point where you say, okay, you know, you pay the premiums anymore. You have the option to sell that policy back to the insurance and the company, and they kind of give you pennies on the dollar, or you can sell it to a third party,
Mhm.
and they'll pay a lot more, but then they assume the premiums and they take over the premiums at that point, and when you die they get the death benefit, and so it becomes an investment at that point, which is a really strange industry. um,
Yeah.
and you know, and um, you know, one, you know, in the way that you, um, in terms of investment, the way that you make money is understanding more accurately when people will die,
Mhm.
and understanding not just that, but understanding how other people think that person will die. And so it was, and I can't say too much more about the methods and stuff that we used, but um, you know, I learned a lot about survival models,
Wow.
which is a specific, like, unique type of machine learning and statistical models of survival analysis, where you have the problem with censored data. Censored data is data where you have a large portion of your data where you don't know the outcome yet.
Mhm.
Um, so if you're trying to predict when people will die and you have a data set of say 100 people, and 10 of those 100 people have died already, you know what their outcome is, and you know how long it took them to die or what age they died. But the other 90 people who are still alive, you don't know when
Mhm.
they're going to die. So
Mhm.
their outcome is in the future. So that's censored. So, you know, there's a whole class of models, and a lot of the machine learning approaches to dealing with this are still very experimental.
Mm-hmm.
And so it's really interesting. And I actually, was able to develop a couple kind of unique ways of machine learning approaches for that. But so I mean, this is a case where um, domain understanding is really important, but there's still a lot of, I think when you're starting in data science, you kind of feel like everything's been figured out, and there's libraries to use for everything, and um, that's not always the case. There's so much room still for innovation, and there's so much. I frequently run into edge cases where the library and standard solution is not enough, or there's some problems with the assumptions that they made um, in that library, and so you have to tweak it, and
Yeah.
that's really that's exciting to me. But
Yeah. Yeah. Thank you so much for that. Actually, it's hard to explain as well when you come to the particular thing. So, moving to the next question, it was more about, like, as you mentioned, that you work in both R and Python. So, would you
mhm.
like to mention, like, which specific scenarios R would be better and which specific scenarios Python, and why, with a
Yeah.
particular example? Yeah.
So I believe that for a lot of data scientists, it's very beneficial to be
Mm-hmm.
bilingual in R and Python. A lot of hardcore Python people would maybe disagree. Um, but I have found R to be more in. So I started in an R, so I have a bias to that. But in terms of data exploration and data visualization, the tidyverse
Mm-hmm.
packages in R are just second to none. There's nothing in R Studio. There's not a Python IDE that is as functional and intuitive as R Studio is for R. Um,
Okay.
and so that's my opinion. When you're doing kind of exploratory analysis, quick, I use it for quick prototyping, really understanding a data set. Um, there's just so many tools in
Mm-hmm.
R and R Studio that make that just really easy and quick.
Yeah.
Python um, has the advantage of it's really great for software engineering and putting things in production. Um, you know, and, um, and stability and other things like that.
Mm-hmm.
So I find that I'm moving more and more towards, and even though R has those tools, um, Python is ahead in terms of API frameworks and machine learning libraries and other things like that. So it's kind of a trade-off, and I think that the nice thing is to port something from R to Python or vice versa. The syntax
Mm-hmm.
is readable in both of them, and a lot of times with programming something, 80% of the work is figuring out the logic and not the syntax. So what are the steps that I need to take? What's the pseudocode that I need to take to get my result, and then that can be easily translated into any syntax of any language once you have that figured out.
So we can just segregate it is more, or like, R is more quicker when it comes to finding out something about the data on the business side, like when there is a requirement, uh,
for for,
how to provide
for
the sites.
yeah, for me, that's the case. There's some people that are very comfortable in Python and can get to the same results.
I think lines
And
of
I
code
think
is also varies, right? R and Python. Lines of code in R is lesser than the lines of code you write in the Python, because Python is more like an interpreter language. So you write
mhm.
everything in the code. So what do you think about that? Like,
Yeah, so I mean, I just think they serve different purposes.
mm-hmm.
And if you look, I mean, R was not written to be a software programming language. It's a statistical programming language.
uh,
And it that's why it was developed, and it does a really great job at that. And any any of the, Python's ability to do that, the same thing,
Mm,
has come in large part because of R.
mm,
That there's a lot of the data analysis, data science tools, even pandas, the
mm.
data frame concept, that came from R.
Oh.
Um, and so
Mhm,
so a lot of, if you're trying out a new method, when I first started looking into some machine learning methods for survival analysis, at that time there weren't any good packages in Python to do that, but they were all in R.
mm.
And so that dictated, okay, I need to do that kind of experimental thing in R. And now that's different, but Python started as a general programming language. It's a lot better, building out an API, or um, you know accessing a machine learning
Mhm,
library. That's a lot easier in Python, and R has had to mimic
mm.
a lot of the things that Python has done, um, in order to bring that in. But with Reticulate by R, the Reticulate package, it's really possible to do things in both R and Python. And I think that instead of the debate of which is better,
Yeah.
it's just what is the best tool
Mm,
for the job that you're trying to accomplish. And sometimes a very important consideration is how quick can I do the tool. If you're more comfortable in Python,
mhm.
then going and learning R, in most cases, doesn't make sense.
Oh,
It doesn't make sense. You know, it, yeah.
yeah.
So, but I
So
found that,
I think, yeah, one programming language is enough actually to start with, I guess. Uh,
mhm,
it's not required to know everything, but that is good to know actually. I wasn't aware that pandas come from R actually. The base of it is
mm.
derived from R.
Well, just the idea is from R. So a lot of the ideas of how, because Python used to just have like
Mm,
NumPy, like arrays, and um, a lot of the data science
mhm,
kind of tools in Python were written and inspired by how
mm.
R handles things. So
Yeah.
um, and it's gone the other way with R. A lot of how R handles things now. Um, so I don't know. I think for most cases, it doesn't matter. I think there's considerations on what you're comfortable in, or what's going to be most sustainable for the business. If you're writing something in R and you're really comfortable in R, but everyone else in the company does Python, from a business perspective, that's maybe not, from a job security perspective, maybe that's good for you individually. But for the business, that's maybe not the most sustainable thing, because it'll be harder for someone else to come in and pick up your code if you're not there.
Yeah. So the next question is along the we actually I also got to know through this that you own a couple of patents in the data science. I wasn't aware at all.
Mm-hmm.
So would you like to share anything about that, like some insights? What kind of patents do you own, and what are those about?
Yeah, so I've filed a number of them. Two of them were just granted in the past couple months. So patents can take um, a couple of years, up to 7 years from the time you file until they're granted. It's just a really kind of long process,
Mm-hmm.
and it can be hard to patent something in the computer science or data science space, um, because of the Supreme Court decisions on you know, and rules on what you can patent. You can't patent something that everyone does already, and or that is kind of common knowledge. Um, my two patents that have been granted so far. The first one is on a way uh, to use a modeling approach to determine the quality of a biological sample.
Mm-hmm.
And so when you're running a sample, such as like a tissue or protein or blood sample through mass spectrometer,
Mm-hmm.
um, you know, whether or not that sample is high quality really matters on the results that you get. And
Mhm.
typically, the only way that you can ensure in quality is to have a very detailed history of what happened to the sample. You know, this is when it was taken. You
Mhm.
know, this is what happened to the sample. It was immediately refrigerated. It was immediately frozen. You know, and kind of detailed entire history of what happened to that sample. Well, we a couple of years ago when I was at a biotech startup, we came up with a way, um, you know, in mass spec, that the end um, sampling approach is actually really expensive. So you don't want to run samples through that, um, you know, that are corrupted, but you don't necessarily know beforehand if they're corrupted or not. Like if the sample gets too hot, the proteins will be denatured, and then your analysis won't make sense. So we came up with a way to you know, produce a model to predict or identify, you know, what level of degradation or what type of degradation has happened to the sample before you have to run the expensive analysis. And so that's what that first patent is about. And
Mhm.
the second one is actually one of my favorite types of subjects. It's a method for using agent-based modeling and evolutionary programming for machine learning. Um, and so it's a kind of a different type of class of machine learning algorithms, kind of mimicking what's happening, uh, you know, in ecology in the natural world, how to
Mhm.
mimic that in a computer in a way to produce more accurate and quicker models. So,
Wow, very
um,
impressive actually. So congratulations
so
on that actually. I wasn't
thank
aware
you.
at all. When I got to know, I was like, oh wow.
Mhm.
Because I think you never mentioned it in the LinkedIn profile as well, right? Um,
So it's down. I mean, I think I have them on there, but you know, that's really what. So I have a background in IP law. My passion is inventing things, and
uh-huh.
I've probably over the past couple of years I've invented in the data science space over 250 different things that could be patented, and that are unique or novel, and really, you know, it's up to the business to decide if it makes sense financially strategy to patent those things. But that's really what, you know, I'm really good at coming up with, you know, out of the box or oddball kind of
Mhm.
solutions to
Yeah.
things, and that's really what my passion is. So you know, I feel like, um, you know, I love being an inventor, and data science is the tool that I use to do that.
Yeah. So yeah, that clearly shows your passion actually towards this data science field. So when did you realize it, and what steps did you take actually to pursue that passion?
Yeah, so and I've talked about this in
Yes.
I think a lot of other podcasts and things too. So my my journey has, uh, you know, has been different than a lot of people. Undergrad and master's degree are in biology and ecology and evolution. That's where I first started
Mhm.
using the tools, data science tools, you know, Python and R,
Mhm.
uh, analysis of large data sets, machine learning methods. You know, my master's thesis was developing computer vision methods for measuring erosion in the desert, for ecologists.
Mhm.
Um, and that's when I started working as a data scientist as well. When I was doing my master's, I started working for a marketing consulting firm,
Mhm.
and I liked that. I was doing science kind of on marketing data,
Mhm.
um, but but you know, I still wasn't sure that I wanted to do data science. I knew that I loved inventing and I liked science and business,
Mhm.
and so that's why I went to law school, to be a patent attorney.
Mhm.
Um, and I realized about a month into law school that I really missed programming, and I really missed doing data science. And so I started, you know, I had a wife and kids when I was in law school, and so in order to help pay the bills, I started consulting as a data scientist while I
Mhm.
was in law school. And I would be sitting in class, in like contracts class, and I would be programming, you know, and while everyone else was taking notes. And I did fine in law school, but that's, you know, that's where my passion was, and it took me a couple years to really figure out that I don't want to be in the legal profession where I'm just writing about cool things that people are doing and inventing.
Yeah.
I want to actually be doing that, and so I made the jump back into data science, and you know, worked for a couple companies full time, but have also been building up my consulting practice, and you know, taught boot camps, and did the trainings with method data science, and just, you know, kind of been all in. And you know, I love the space that I'm in now.
Mhm.
You know, like I'm doing exactly what I want to be doing. So.
Okay, sounds good. And when we talk a lot more about this data science field, actually, how much is the boom and the reality, and any real challenges and obstacles you see in this area, the way it is growing?
So I think that, you know, I think that for most companies that have data,
Mm-hmm.
um, data science can make a huge difference. Um, and so I think that part of the hype is real.
Mm-hmm.
That yes, that but the other side of the equation is that the business has to be ready
Mm-hmm.
in order to do that. And I think that's actually where the hype comes in. I think so many companies hire data scientists just because everyone else is hiring data scientists. It's a lot of work, you know, to get an organization, not just to get the data and the infrastructure ready so that you can actually do data science and machine learning. You know, there's a lot of work in order to get an organization mature enough. But
Mm-hmm.
at the same time, the the business side, you know, the executives and business side have to be willing um, to make the changes they need to trust and have their data really, or have their company really be a data science driven business.
Mm-hmm.
And that's, you know, I think that's really hard to do, and I think that is responsible for a lot of the turnover in data science. You know, I think data scientists come in
Mm-hmm.
with expectations about, you know, what the company will be is ready to do and what they want to do, and the reality is way different. You know, so I firmly believe that data science has the power to transform just about any company that has data. You know, or can collect data. You know, I think a lot of my clients too, they start out and they don't actually have a lot of data, but we can say, okay, let's build out a plan to go and collect the data that you need. Um, but the real challenge is whether they're actually ready for that. You know, and I think that's where the hype comes in. Um, that
Mm-hmm.
you know, and when I say data science, I don't just mean deep learning. You
Uh-huh.
know, I mean it's the whole process, and the whole spectrum of data science
Okay.
of actually, um, yeah. I don't know if that answers your question, but
Yeah, yeah, yeah. That answers my question actually. So, when we say that, like these all the automation frameworks are coming in, which can automate your machine learning. So, do you see that these automation frameworks are making the job easier for the data scientist, and or is it kind of a disadvantage that it is getting automated?
so I think, you know, in my mind, there's no, I mean, at a high level, there's not a difference from the tools that we already use. So if you use like import linear model from sklearn, you know,
Mm-hmm.
how many of us really know or think about, what are all the the steps under the hood that are happening when we do that, you know, or if we use keras, or
Mm-hmm.
you know, like those are tools. And then, you know, AutoML, you know, whether it's data robot or H2O or whatever, is just kind of the next level of that. And so I think they can provide immense value to a data scientist. They're just tools, and they can make tedious and hard parts of the job happen a lot quicker.
Mm,
So the data scientist is focusing on the parts that they need to.
mm,
The disadvantage is whenever you, and this is with any tools, that if you don't understand the assumptions that go into using that tool, then they can come back to bite you. You know, that you need to understand um, why your tool is doing the things that it does.
yeah, yeah.
As a data scientist, the business doesn't necessarily need to understand, but you do as a data scientist, and that's, you know, that's why I think um, like I don't really feel like AutoML is going to replace a good data scientist.
It is more or like just help to the data scientists, I guess, make their job
Yep.
easy so that they can
Yep.
just go on
Yeah.
the insights. Yeah. Okay, that sounds good actually. Then one more question that this is my favorite question actually, because I lot more time struggle. How do you describe machine learning or data science to any non-technical user, like person who doesn't know anything about data science or machine learning? What would be the best way?
Oh, I don't know about the best way.
Like, how do you describe?
But how do I do it? Okay, so um, how I describe it is that, you know, I typically will walk through an example of, you know, in order for an algorithm or a computer or whatever to learn how something, you know, to learn a result or make a prediction, you have to have um, historical examples. You have to have data to train and teach it, you know, what the outcome is. And the, you know, the very, at a very high level, what machine learning does is learns what patterns are in the data to predict the certain outcome of what have happened in your historical data in the past,
Mhm,
and then you can apply that in the future. You know, if they are slightly more technical, then I'll use an example, a simple example of linear regression, of
mhm,
how that works, and say, you know, at a high level, that's really the same process of having, you know, predictors and an outcome. You know, that's really what machine learning is. And there's a lot more that happens under the hood,
mhm,
um, but that's what's happening. And it's important for the non-technical user to know that any model is dependent on the data that it's seen or that it's been trained on. You
mhm,
know, so if the data that you have access to is different than the data that you want to make the prediction on,
mhm.
then you're going to run into problems, no matter what method that you use, and that's something that you need to be aware of. But
Yeah, yeah.
you
That
know,
makes sense. Thank you for that.
so yep.
Uh, it truly shows actually you lead the area you are passionate about actually, because you have a lot more to explain, and I guess we are like, running out of time now. It's like, because you have a lot more to share actually, so that truly shows your leadership in that particular area. So how do you describe your leadership style when it comes to working actually?
So I don't like to micromanage people.
That's very good.
I
I like
Yeah,
that.
uh, and I like to hire people that are curious,
Mhm,
and that I can help them and am passionate, and that
mhm,
I can help them understand what we're trying to accomplish, and that they can come up with the best way that they know how to do that. You know, and so that's how I prefer to be managed. I hate being micromanaged
that's
because
great. Yeah.
you know, and I think a lot of data science are that way, and it's especially hard when you're micromanaged by someone who doesn't understand what you do.
Because
um,
I feel
um,
if you get micromanaged, you do not get like the way you thought, like, you have to think out of box. You need your space to,
yep, yep,
invest time to figure it out. So it's
yep.
like you need that space actually. I don't think micromanaging helps anymore to any person to grow.
Well, and it's ultimately not good for the business
Yeah.
too.
Not a
I think,
healthy thing actually, I feel. Healthy environment. Yeah.
yeah. So I, you know, I like to hire uh, people that I can trust to help
Mm.
solve problems.
Yeah.
You know, and then I can trust them to say, even if they haven't done something before, can you go figure this out? and recommend us the best way to do it, or build the best way that you know how to do that. And I'll give input, but a lot of times it's something I've never done before either. So I don't know. I mean, you can't, go do the research, go figure it out,
Yes.
and and that we can kind of brainstorm and collaborate together. So
Yeah. That definitely, I totally agree with you actually. That
mm,
it's very important. Trust and then no micromanaging. Yeah.
mhm,
So,
mhm.
any kind of advice actually for the students or the professionals who are trying to grow in this area? Any kind of advice or any kind of a skill set that you recommend them to, pursue?
So I mean, I think there's lots of good lists about the basic skills that you need,
Mm,
and they're good. And I think the biggest thing the biggest piece of advice I would have is you have to have passion
yeah.
for it,
Mm,
and that comes through in the type of things that you work on.
mhm,
So one example is while I was still doing law school, I for fun I built a bot, that for my wife, that went to her favorite retail sites like Nordstrom's, found the sales, then used a machine learning algorithm to predict, um, predict what the best sales would be. And I did that for fun. That's something that shows what my
yes.
passion is. And so I look at people, that's something that comes through, and not like what certifications do they have,
Mm,
because when I look at that, see someone who has a ton of certifications, that says more to me they're passionate about getting certifications, you
mm,
know and I want to hire people that are passionate about solving problems.
yeah.
So I know that's my advice.
Yeah. So that's true. That have the passion and interest what you do.
Yeah,
So thank you so much. It was really a
you're
great
welcome.
session. Actually, I think you were very insightful when it came to talking about specific use cases or data science, machine learning, and that clearly shows your interest as well. So thank you so much for your time.
Thank
I really
you.
appreciate it because it is very
It was a
early morning
pleasure.
for you. So thank you so much. And once the podcast is available, actually, I'll keep you informed. I will provide
Okay.
actually all your social media accounts details as well in my post so that people who want to connect with
Okay.
you, they can directly connect and ask for the guidance. So
Okay.
thank you so much. Yeah.
Sounds great. Thank you.
Yeah.
have
Thank you.
have a great day.
Yeah.
Thank
Thank you.
you.